on the center of the solar system or not. And we try to produce models that explain the problem. So here's the problem, or the question of the day. We try to produce models to describe it, and we make observations, measurements, to see if our models are correct. And we feed that information back into the models. We try out the models, we test it against more observations, and you go round and round. And this is kind of the fundamental, this is the way all of these basic first 5 subjects use basically this method of inquiry. So in 2003, the way this system works, my kind of mental conception of this modeling process is three things. And this applies to you have a homework problem. How do you attack a homework problem? You're going to need to describe the motion. You're going to need to choose the physical laws, pick, I'll call it because it's short, the physical law that you want to apply, like F equals ma, conservation of energy, conservation of momentum. You got to know which physical laws to apply. And then finally, third, you need to apply the correct math. And that's really most dynamic problems can be broken down this way. This is the way I like to conceptually break them down. You might have another model, but this is the way I'm going to teach it. So you need to describe the motion, pick the correct physical laws to apply to the problem, and be able to do the correct math, solving the equation of motion, for example. And this is what fits in our models box. And we test it against observations and measurements and improve those things over time.